Look at your family tree, trace your father's line backward through time, your father, his father, his father's father. Keep going. Back through centuries, through millennia, through the rise and fall of empires. Eventually, if you're male, that line leads to one of the most mysterious and terrifying chapters in human prehistory. A chapter written not in books or stone tablets, but in the very structure of your DNA. If you're listening to this to fall asleep, perfect. That's exactly why I make these videos. So maybe subscribe and tell me where you are right now and what time it is. I love seeing the comments roll in from around the world. Berlin at breakfast, Sydney at sunset, Chicago at midnight. All of us pondering the same ancient mysteries together. 7,000 years ago, something unprecedented happened to humanity. Something so catastrophic that its echoes still reverberate through every cell in your body today. In the span of just a few centuries, 95% of all male lineages on Earth simply vanished. Not through disease, not through natural disaster, but through something far more deliberate and far more chilling. This isn't speculation or ancient mythology. This is hard genetic evidence discovered only recently by scientists studying the deepest layers of human DNA. They call it the Neolithic Y chromosome bottleneck, and it represents one of the most dramatic population collapses in human history. A collapse so severe that for every man who survived to pass on his genes, 17 women did the same. The implications are staggering, and the story they tell challenges everything we thought we knew about our peaceful agricultural ancestors. To understand what happened, we need to talk about chromosomes. Not the complicated textbook version, but the simple truth of how genetic memory works. Every cell in your body contains 46 chromosomes, arranged in 23 pairs. 22 of those pairs mix and match between your parents, shuffling genetic information like cards in a deck. But that 23rd pair is different. It determines your biological sex and it carries information in a very special way. If you're female, you have 2 X chromosomes, one from each parent. But if you're male, you have 1 X chromosome from your mother and 1 Y chromosome from your father. And here's the crucial detail that makes this story possible. That Y chromosome passes from father to son virtually unchanged, generation after generation. It's like a genetic time capsule, preserving information about male lineages stretching back thousands of years. Think of it this way. Your Y chromosome is essentially identical to your father's Y chromosome, which was essentially identical to his father's Y chromosome, and so on. Mutations occur, but they're rare and they accumulate slowly over time. This makes the Y chromosome an incredibly powerful tool for tracking male ancestry. Scientists can look at modern populations, compare their Y chromosomes, and trace back through time to see when different male lineages split apart or disappeared entirely. When geneticists first started doing this kind of analysis in the early 2000s, they expected to see a relatively steady pattern of male genetic diversity stretching back through human history. What they found instead was shocking. Around 7,000 years ago, there was a massive crash in male genetic diversity. A bottleneck so severe that it looked like the male population had collapsed to almost nothing before slowly recovering over the following millennia. A genetic bottleneck occurs when a population shrinks dramatically, losing most of its genetic diversity in the process. Imagine a bag full of different coloured marbles. If you suddenly removed 90% of the marbles at random, you'd be left with far fewer colours represented. That's essentially what happened to human Y chromosome diversity 7,000 years ago, except the reduction wasn't random. It was systematic, targeted, and absolutely devastating. The numbers are almost incomprehensible. Analysis of modern Y chromosome data suggests that during the worst phase of this bottleneck, the effective male population size dropped to just 1/20th of what it had been before. In practical terms, this means that for every 100 male lineages that existed before the bottleneck, only 5 survived to contribute to future generations. The other 95 simply disappeared from the genetic record forever. But here's what makes this discovery even more puzzling. When scientists looked at mitochondrial DNA, which passes from mother to daughter and tracks female lineages, they found no corresponding bottleneck. Female genetic diversity remained relatively stable throughout this period. This wasn't a natural disaster that killed men and women equally. This wasn't disease or famine or climate catastrophe. This was something that specifically targeted male lineages while leaving female lineages largely intact. The timing of this bottleneck is significant. 7,000 years ago places us squarely in the Neolithic period, the time when humans were transitioning from hunter-gatherer societies to settled agricultural communities. This was supposed to be the dawn of civilization, the moment when humans learned to grow crops, domesticate animals, and build permanent settlements. The traditional narrative presents this as a peaceful revolution that allowed human societies to flourish and grow, but the genetic evidence tells a different story. The very period that we celebrate as the beginning of human progress was also marked by an unprecedented collapse in male genetic diversity. Something was happening during the early agricultural period that was systematically eliminating male lineages on a massive scale. The question that haunted researchers was simple but profound. What could cause such a dramatic and sex-specific population bottleneck? The answer, when it finally emerged, painted a picture of the Neolithic period that was far darker than anyone had imagined. Archaeological evidence began to support what the genetics were suggesting. Excavations across Europe and Asia revealed a disturbing pattern of violence during the late Neolithic period. Not the occasional skirmish or isolated conflict that might be expected in any human society, but systematic, organized warfare on a scale that hadn't been seen before in human history. Fortified settlements began appearing across the landscape, villages surrounded by massive earthworks and wooden palisades, defensive structures that required enormous investments of time and labor to build. These weren't built to keep out wild animals, they were built to keep out other humans. Even more disturbing were the massacre sites, locations where entire communities had been wiped out in single episodes of extreme violence. Bodies dumped in mass graves, many showing signs of severe trauma. Men, women, and children killed with axes, clubs, and arrows. But the pattern of who was killed and who was missing from these sites began to tell a story. The dead were predominantly men and children. Young women were notably underrepresented in these mass graves, suggesting they'd been taken alive, captured, absorbed into the communities of their attackers. This pattern fit perfectly with what the genetic evidence was showing. Male lineages being eliminated while female lineages continued, just in different locations and under different circumstances. The scale of these conflicts was staggering. Archaeological sites across Central Europe revealed evidence of repeated massacres, entire settlements destroyed and abandoned, populations fleeing to defensible positions in desperate attempts to survive. This wasn't random violence or occasional raids. This was systematic warfare aimed at the complete elimination of rival communities. But why? What had changed about human society that could trigger such unprecedented levels of violence? The answer lies in the fundamental transformation that agriculture brought to human social organization. Hunter-gatherer societies were remarkably egalitarian in many ways. Small mobile groups where cooperation meant survival. Leadership was often temporary and situational. Resources were shared because hoarding was impossible when you had to carry everything you owned. Conflicts certainly existed, but they were typically resolved through avoidance. If tensions arose between groups, one could simply move to a different territory. The landscape was vast and the population was sparse. Agriculture changed everything about this equation. For the first time in human history, people were tied to specific pieces of land. Your crops were rooted in particular soil. Your granaries were fixed structures that couldn't be moved. Your livestock required pasture and water sources that existed in defined locations. Territory suddenly mattered in a way it never had before. More importantly, agriculture created something that had barely existed in hunter-gatherer societies: surplus. For the first time, human community could produce more food than they needed for immediate consumption. This surplus could be stored, accumulated, and controlled. And with surplus came inequality. Some individuals and families became more successful farmers than others. Some controlled better land or larger herds. Some accumulated more stored grain or more valuable livestock. This accumulation of resources created the first true wealth disparities in human history, and wealth disparities created something else entirely: social stratification, hierarchies, the emergence of elites who controlled resources and commoners who depended on them for survival. These weren't the flexible, temporary leadership roles of hunter-gatherer societies. These were permanent positions of power based on control of agricultural resources. But perhaps the most significant change that agriculture brought was in kinship organization. Hunter-gatherer societies were typically organized around flexible band structures where membership could shift based on marriage, friendship, or practical considerations. Agricultural societies increasingly organized themselves around kinship groups, extended families, clans, lineages that traced their ancestry back through multiple generations. And here's where the story becomes crucial for understanding the Y chromosome bottleneck. Many of these agricultural societies became patrilineal. Descent was traced through the male line. Inheritance passed from father to son. Children belonged to their father's clan rather than their mother's. Women typically married into their husband's kinship group, joining his lineage and leaving their birth families behind. This patrilineal organization had profound genetic implications. In a patrilineal clan, all the men were related through their fathers. They shared similar Y chromosomes because they descended from common male ancestors. The women in the clan came from different lineages, bringing diverse mitochondrial DNA from their birth families. But the men represented a single genetic line stretching back through generations. Now imagine what happens when patrilineal clans go to war. When one clan defeats another, they don't just kill individual men, they eliminate entire male lineages. Every man in the losing clan carries essentially the same Y chromosome. So destroying that clan removes that particular genetic signature from the human gene pool entirely. The women might be captured and absorbed into the winning clan, preserving their mitochondrial DNA but ending their original clan's patrilineal line forever. This is the mechanism that could explain the Neolithic Y chromosome bottleneck. Not random violence, but systematic warfare between patrilineal clans where victory meant the complete genetic erasure of the losing group's male line. Computer simulations have shown that this type of clan-based warfare could indeed produce the dramatic bottleneck pattern seen in the genetic data. The archaeological evidence supports this interpretation with disturbing clarity. The massacre sites don't show random violence or simple raids for resources. They show the systematic elimination of entire communities. The Talheim death pit in Germany, dating to around 5000 BCE, contained 34 bodies representing what appears to be an entire small community. Men, women, and children, all killed with characteristic linear pottery culture weapons. But significantly, young women were underrepresented among the dead, suggesting they had been taken alive. This pattern repeats across dozens of sites throughout Central Europe during the late Neolithic period. Herxheim in Germany contained the remains of over 1,000 individuals, all showing signs of systematic butchery and consumption. This wasn't survival cannibalism or ritual sacrifice of enemies. The scale suggests something far more organized. Entire communities being processed and consumed by their conquerors. The weapons found at these sites tell their own story. Stone adzes, wooden clubs, flint arrows, the same tools used for farming and daily life, repurposed for warfare. The injuries show repeated blunt force trauma to the head, systematic breaking of leg bones, evidence of torture and mutilation. This wasn't quick, efficient killing. This was deliberate brutality designed to terrorize and eliminate. But the geographic patterns reveal something even more significant. These massacre sites cluster in specific regions and time periods. They're not randomly distributed across the landscape. Instead, they mark the boundaries between different cultural groups. The places where expanding agricultural populations came into conflict with each other or with remaining hunter-gatherer communities. The linear pottery culture, which spread across Central Europe between 5,500 and 4,900 BCE, shows clear evidence of increasing violence over time. Early settlements were open and undefended. Later sites are heavily fortified, surrounded by ditches and palisades. The final phase shows widespread abandonment as communities fled to defensible positions or were simply wiped out entirely. This pattern suggests that the violence wasn't random or occasional, it was systematic and escalating. Communities were engaged in what can only be described as total war, not just fighting for resources or territory, but for the complete elimination of rival groups. The kind of warfare that would leave archaeological signatures exactly like what we see in the late Neolithic record. The genetic data provides the broader context for understanding these archaeological discoveries. The Y chromosome bottleneck wasn't a brief event. It lasted for over 1,000 years, roughly from 7,000 to 5,000 years ago. This matches perfectly with the period of increasing violence seen in the archaeological record. Generation after generation of warfare that systematically eliminated male lineages across vast regions of the inhabited world. The recovery from the bottleneck is equally telling. Around 5,000 years ago, male genetic diversity began to recover. This coincides with the emergence of larger, more complex societies, the first cities, the first states, the first armies organized on a scale that could impose peace across wider territories. The transition from clan-based warfare to state-level organization seems to have ended the period of systematic lineage elimination. But the mechanism that created the bottleneck reveals something profound about human nature during this critical period of our development. The transition to agriculture didn't just change how humans obtained food, it fundamentally transformed human social organization in ways that made unprecedented levels of violence not just possible, but almost inevitable. The combination of fixed territories, accumulated wealth, patrilineal kinship systems, and competition for resources created a perfect storm for the kind of systematic warfare that could eliminate entire genetic lineages. Communities weren't just fighting for survival, they were fighting for genetic continuation. The stakes couldn't have been higher. Yet even as this picture emerges from the genetic and archaeological evidence, questions remain. Alternative explanations for the Y chromosome bottleneck continue to be proposed and debated. Some researchers argue that the pattern could be explained without invoking widespread warfare. Perhaps social changes alone could account for the dramatic reduction in male genetic diversity. These alternative explanations deserve serious consideration because they address some of the limitations in the warfare hypothesis. While the archaeological evidence for violence is compelling, it represents only a small fraction of Neolithic settlements. Most archaeological sites from this period show no signs of systematic destruction or mass casualties. It's possible that the massacre sites, dramatic as they are, represent exceptional events rather than the normal pattern of life during the Neolithic transition. One alternative theory focuses on reproductive inequality within patrilineal societies. In these systems, successful men could accumulate multiple wives, while less successful men might never reproduce at all. Over time, this could create a pattern where a small number of highly successful male lineages contributed disproportionately to future generations, while many others simply faded away through lack of reproductive success rather than violent death. Anthropological studies of modern patrilineal societies show exactly this kind of reproductive skew. In some cultures, wealthy or high-status men maintain multiple wives and father dozens of children, while poorer men remain unmarried and childless. If this pattern was amplified during the Neolithic transition, when agriculture first created significant wealth differences between families, it could potentially explain the Y chromosome bottleneck without requiring widespread warfare. The mathematics of this scenario are surprisingly powerful. Computer models show that even modest differences in reproductive success between patrilineal clans, combined with occasional clan splitting and migration, can produce bottleneck patterns similar to what we see in the genetic data. A few highly successful lineages expanding rapidly, while others gradually disappear through demographic processes alone. This peaceful explanation gains support from ethnographic studies of contemporary societies that show similar genetic patterns without corresponding evidence of systematic violence. Some modern populations display Y chromosome diversity patterns that mirror the Neolithic bottleneck, despite living in relatively peaceful conditions. The key factor appears to be social organization rather than warfare specifically. Another factor that could contribute to the bottleneck is migration and founder effects. As agricultural populations expanded into new territories, they often did so in small groups led by a limited number of male founders. If these founding populations were successful and grew rapidly, they could create regions where Y chromosome diversity was artificially low simply because the initial colonizing group contained only a few male lineages. The expansion of the linear pottery culture across Central Europe provides a potential example of this process. Archaeological evidence shows this culture spreading rapidly from its origins in the Danube Valley to cover vast areas of Central and Western Europe in just a few centuries. If this expansion was carried out by relatively small groups of colonists, each led by a few patrilineal families, it could explain the reduced Y chromosome diversity seen in European populations without requiring systematic elimination of existing male lineages. Genetic drift also plays a role in small populations. When communities are organized into small patrilineal clans, random demographic fluctuations can have outsized effects on genetic diversity. A clan might disappear simply because its male members happen to have only daughters for a few generations, or because disease or accident claimed key reproductive age men. Over time, these random losses could accumulate to create the bottleneck pattern. Climate change during the Neolithic period might have amplified all of these effects. The transition to agriculture coincided with significant environmental shifts that created both opportunities and challenges for human populations. Successful adaptation to these changes might have allowed some lineages to thrive, while others struggled and eventually disappeared. The 8.2 kiloyear event, a period of rapid cooling that occurred roughly 8,200 years ago, created challenging conditions across much of the Northern Hemisphere. Agricultural communities that had adapted to warmer conditions suddenly faced crop failures and resource scarcity. Some communities might have thrived by adapting quickly to the new conditions, while others failed and disappeared entirely. This kind of environmental selection could contribute to the genetic bottleneck without requiring direct conflict. Yet the peaceful explanations faced their own challenges when confronted with the archaeological evidence. The massacre sites from the Neolithic period are not isolated anomalies. They represent a consistent pattern of extreme violence that spans centuries and covers vast geographic areas. The systematic nature of this violence, the evidence for torture and mutilation, the careful selection of victims, all suggest organized warfare rather than random demographic processes. The fortification of Neolithic settlements tells a similar story. The massive investment of labor required to build defensive earthworks and palisades only makes sense if communities faced serious external threats. These weren't built to impress neighbors or mark territorial boundaries. They were built by people who expected violent attacks and were willing to divert enormous resources from food production to defense. The pattern of who was killed and who was missing from massacre sites also supports the warfare hypothesis. The underrepresentation of young women among the dead suggests systematic capture rather than indiscriminate slaughter. This pattern makes little sense in the context of disease, famine, or other natural causes of population decline. It strongly suggests organized raids designed to eliminate male lineages while preserving female reproductive capacity. Recent advances in ancient DNA analysis have added new dimensions to this debate. Genetic material extracted from Neolithic skeletons allows researchers to trace population movements and relationships with unprecedented precision. These studies have revealed complex patterns of migration, admixture, and population replacement that occurred during the critical period of the Y chromosome bottleneck. In some regions, ancient DNA shows clear evidence of population replacement, with new genetic signatures appearing suddenly in the archaeological record while older ones disappear. This pattern could support either the warfare or migration hypotheses, depending on whether the replacement was violent or peaceful. Distinguishing between these scenarios requires careful analysis of both genetic and archaeological evidence from the same sites. The corded ware culture, which appeared across much of Europe around 2900 BCE, shows particularly dramatic genetic signatures. Ancient DNA from corded ware sites reveals a population that was genetically distinct from the earlier Neolithic farmers who had occupied the same territories. The transition appears to have been rapid and complete, with little genetic continuity between the earlier and later populations. This pattern could represent a massive migration of new populations from the steppes of Eastern Europe, bringing with them new technologies, new social systems, and new genetic lineages. If this migration was violent, it could explain part of the Y chromosome bottleneck. If it was peaceful, it might represent a different kind of demographic process altogether. The bell beaker culture provides another example of rapid cultural and genetic change during the late Neolithic period. This culture spread across Western Europe around 2500 BCE, associated with distinctive pottery, metalworking techniques, and burial practices. Ancient DNA analysis reveals significant genetic turnover associated with the bell beaker expansion, particularly in male lineages. Some researchers interpret this as evidence for male-mediated migration, with small groups of bell beaker men establishing themselves as elites within existing populations and gradually displacing local male lineages through social and economic advantages rather than direct violence. This scenario could contribute to the Y chromosome bottleneck while leaving female lineages relatively intact. The complexity of these genetic patterns suggests that no single explanation is likely to account for the entire Y chromosome bottleneck. Different regions and time periods probably experience different combinations of warfare, migration, social change, and demographic processes. The challenge for researchers is to determine the relative importance of each factor in creating the overall pattern. New analytical techniques are helping to address this challenge. Researchers can now model complex demographic scenarios and compare their predictions to observe genetic patterns with increasing sophistication. They can also integrate genetic data with archaeological and environmental evidence to build more comprehensive pictures of Neolithic population dynamics. One promising approach involves analyzing Y chromosome diversity at finer geographic and temporal scales. Instead of looking at continent-wide patterns over millennia, researchers are examining regional differences over centuries or even decades. This higher resolution analysis reveals that the bottleneck was not uniform across all populations. Some regions show more severe reductions in diversity than others, and the timing varies between different areas. These regional patterns provide clues about the underlying causes. Areas with stronger archaeological evidence for violence tend to show more severe Y chromosome bottlenecks. Regions with evidence for rapid cultural change often display corresponding genetic turnover. Areas with stable archaeological sequences typically show less dramatic genetic patterns. The picture that emerges from this finer scale analysis is one of mosaic complexity rather than uniform catastrophe. The Neolithic period saw a patchwork of different demographic processes occurring simultaneously across different regions. Some areas experienced violent conflict that eliminated local male lineages. Others saw peaceful migrations that gradually replaced existing populations. Still others witnessed social changes that altered reproductive patterns without necessarily involving violence or migration. This complexity helps explain why the debate over the Y chromosome bottleneck remains active despite decades of research. The phenomenon probably reflects multiple causes operating at different scales and intensities across the inhabited world. Understanding it requires not just genetic analysis, but careful integration of archaeological, environmental, and anthropological evidence from many different contexts. The implications of this research extend far beyond academic debates about Neolithic demographics. The Y chromosome bottleneck represents one of the most dramatic examples of how cultural changes can influence genetic evolution. It demonstrates that human genetic diversity is not just shaped by environmental factors or random demographic processes, but by the specific ways that societies organize themselves and interact with each other. The transition to agriculture was not just an economic revolution. It was a social and genetic revolution that fundamentally altered the trajectory of human evolution. The bottleneck shows that this transition was not smooth or inevitable, but involved periods of intense disruption that left permanent marks on the human genome. Modern populations still bear the genetic signatures of these ancient events. The reduced Y chromosome diversity that characterizes many contemporary populations reflects the demographic catastrophes of the Neolithic period. In some sense, we are all descendants of the survivors of this forgotten prehistoric crisis. Yet the recovery from the bottleneck also demonstrates human resilience and adaptability. Despite losing 95% of male lineages, human populations not only survived but eventually flourished. The development of larger, more complex societies provided new forms of social organization that reduced the intensity of lineage-based competition and allowed genetic diversity to recover. The story of the Y chromosome bottleneck thus becomes a story about the relationship between culture and biology, between social innovation and genetic survival. It shows how human societies can create conditions that threaten their own genetic diversity, but also how they can develop solutions that allow recovery and continued evolution. As you drift towards sleep tonight, consider the genetic journey that brought you to this moment. Your Y chromosome, if you carry one, has survived an ancient catastrophe that eliminated most of its companions. Your lineage is one of the few that made it through the demographic bottleneck of the Neolithic transition. You are quite literally a descendant of survivors, carrying in your cells the molecular memory of humanity's most challenging prehistoric crisis. The peaceful fields and villages we associate with early agriculture were built on foundations that may have been far more violent and competitive than we usually imagine. The transition to farming created not just new ways of obtaining food, but new forms of social organization that made systematic warfare possible for the first time in human history. Whether that warfare was the primary cause of the Y chromosome bottleneck remains an open question, but the genetic evidence is clear that something unprecedented happened to human male lineages during the Neolithic period, something that eliminated most of the genetic diversity that had accumulated over hundreds of thousands of years of human evolution. The mystery continues to unfold as new evidence emerges from archaeological sites and ancient DNA laboratories around the world. Each discovery adds another piece to the puzzle, gradually revealing the complex story of how our species navigated one of its most challenging transitions. The forgotten war, if it was a war, shaped the genetic landscape of modern humanity in ways we're only beginning to understand. The more researchers study this period, the more they realize that the genetic and archaeological evidence may be telling us about something even more fundamental than warfare or social change. They may be revealing the first glimpse of what happens when human societies cross a critical threshold of complexity and begin to reshape not just their environment, but their own evolutionary trajectory. The Neolithic transition wasn't just about learning to farm. It was about learning to live in permanent settlements with stored resources and fixed territorial boundaries. For the first time in human history, communities couldn't simply walk away from conflict. They had to defend what they had built, and they had to compete for the best agricultural land in ways that hunter-gatherers never needed to consider. Archaeological surveys across the fertile river valleys of Europe and Asia reveal the intensity of this competition. Sites that begin as small open farming villages gradually develop defensive features over time. First, simple ditches around the settlement perimeter, then deeper ditches backed by earthen walls. Finally, elaborate fortification systems with multiple defensive rings, watchtowers, and heavily fortified gates. The investment of labor required for these defenses was enormous. Building the palisades and earthworks at some late Neolithic sites would have required thousands of person-hours of work. Entire communities dedicating weeks or months to construction projects designed purely for defense against other human beings. This level of investment only makes economic sense if the threat of attack was constant and severe. Inside these fortified settlements, archaeologists find evidence of communities living under siege conditions. Storage pits dug deep underground to hide grain supplies. Wells located within the defensive perimeter to ensure water access during attacks. Weapons caches hidden in residential areas. The daily life artifacts paint a picture of people who expected violence and prepared for it systematically. But perhaps the most telling evidence comes from the abandonment patterns. Many of these heavily fortified sites show sudden abandonment around 5000 BCE. Not gradual decline or peaceful relocation, but abrupt departure with valuable items left behind. pottery still sitting on hearths, tools scattered on floors, grain stores left to rot in storage pits. These communities fled quickly, and they never came back. The genetic data helps explain why these sites were abandoned rather than reoccupied. If the defending communities were completely eliminated, their Y chromosome lineages would disappear from the gene pool entirely. The attackers might have had no interest in occupying the conquered territory, preferring to return to their own lands with captured women and portable wealth. The empty settlements would stand as monuments to vanished lineages, eventually crumbling back into the landscape. This pattern of conquest without occupation appears repeatedly in the late Neolithic archaeological record. Destroyed settlements that are never rebuilt, defensive systems that are breached and burned but not repaired, cultural traditions that end abruptly with no gradual transition to new practices. The archaeological signature looks exactly like what you'd expect from systematic lineage elimination rather than territorial conquest. The truth is, we may never know exactly what happened during those dark centuries when 95% of human male lineages vanished from the genetic record. The evidence points in multiple directions, sometimes contradictory, always incomplete. What we do know is that something profound occurred during humanity's transition to agriculture, something that left permanent scars in our DNA and scattered evidence across the archaeological landscape of 3 continents. Whether it was systematic warfare between patrilineal clans, dramatic social restructuring that concentrated reproductive success among a few dominant lineages, or some combination of violence and demographic change, the Neolithic bottleneck reminds us that human progress has never been linear or guaranteed. The same innovations that allowed our species to build civilizations also created new forms of competition and conflict that nearly erased most of humanity's male genetic heritage. And if you want to understand why the Neolithic Y chromosome bottleneck shook genetics so hard, you have to picture what the data actually looks like when it first comes in. A researcher downloads thousands of Y chromosome sequences from modern populations. Not names or faces, just strings of A's, T's, C's and G's. They align them. They count shared mutations. They build a branching tree, one that should, in theory, show a slow, steady widening as lineages split over time. But instead of a smooth tree, you get a trunk. A long, narrow segment where many branches should exist but don't. And then, above it, a sudden explosion. A burst of lineages radiating outward in a way that looks less like gradual diversification and more like a rebound after near extinction. That trunk, that narrowing, sits right around the middle Holocene, roughly 7,000 years ago, give or take, depending on region, dataset and method. The exact dates shift slightly, based on calibration and assumptions, but the shape remains. And in population genetics, the shape is everything, because you can argue about a date, you can argue about a sample, you can argue about whether the bottleneck was 95% or 90% or only 80%, but you can't easily argue away a tree that looks like it was squeezed in a vice. So the first job becomes translation, turning that genetic shape into human reality. What does collapse in male lineage diversity mean on the ground? It doesn't necessarily mean that 95% of men died, not directly. It means 95% of patrilineal lines stopped producing sons who later produced sons. A lineage can vanish, even if some men survive, if they don't reproduce. It can vanish if they have only daughters. It can vanish if their sons are absorbed into other kin groups and no longer reproduce under the same lineage identity. It can vanish if the social rules of inheritance and status shut them out of mating opportunities. The bottleneck is not a single kind of event. It's a result, a signature, and multiple social and demographic mechanisms can produce the same signature. That's why the best researchers don't start with a story, they start with constraints. Constraint 1, the bottleneck is male biased. That's the core. Mitochondrial diversity does not collapse in the same way. Autosomal DNA does not show an equivalent crash. Whatever happened didn't reduce the entire population to a tiny remnant. It targeted or filtered male lines more than female lines. Constraint 2. It lasts long enough that it can't be explained by one short disaster alone. The genetic signature implies persistence across multiple generations. Not one bad year, not one epidemic wave, not one volcanic winter that hits and passes. Something structural enough to keep effective male lineage numbers low for centuries. Constraint 3. It aligns with a period of massive cultural reorganization. Agriculture is spreading. Settlements densify. Land becomes property in a new sense. Bounded, inherited, contested. Surplus appears. Storage appears. Social stratification begins to harden. You don't have to decide whether early farmers were peaceful or violent as a category. You just have to admit that the rules of life changed. And the moment the rules change, selection pressures change too. Not just biological pressures, but social pressures that determine who gets to reproduce. Now picture a world of small farming villages scattered across river valleys and loess plains. Fields of emmer wheat and barley, pens of goats and sheep, clay ovens, storage pits lined with baskets, the smell of smoke embedded in everything. This is not the distant mythic beginning of civilization. This is daily work, grinding grain, repairing fences, managing winter fodder, watching for predators, wolves for the animals, but also humans for the grain. Because stored food is a new kind of vulnerability. A hunter-gatherer band can suffer hunger, but they don't keep months of calories in one place for a raiding party to take. A farming village does. And the moment you have something that can be stolen in bulk, you create an incentive for organized theft. That's not ideology, that's arithmetic. And when organized theft becomes possible, defense becomes a technology. This is where the archaeology stops being abstract and starts becoming physical. Because fortifications are not metaphors, a ditch is a ditch, a palisade is a palisade, a gate is a choke point designed to slow bodies down. In parts of Neolithic Europe, you see causewayed enclosures, large circular earthworks with ditches and banks, sometimes with multiple rings. Their purpose is debated. Some may have been gathering places, ritual centres, markers of territory, or all of those. But what's undeniable is that they could be defended, and some show evidence of violence and burning. You also see settlements perched on defensible hills. You see walls. You see sites rebuilt after destruction, sometimes with more robust defences than before. Then you see something that is harder to rationalise away. Human bones with patterns. Not just violence happened, but what kind of violence and how it was administered. Blunt force trauma concentrated on skulls, arrow points embedded in vertebrae, defensive wounds on forearms, fractures that suggest a person raised an arm to block a strike, multiple impacts on the same individual, the kind of injuries that don't fit hunting accidents, and in some contexts you see mass death, multiple individuals deposited together, not over decades, but in what appears to be a single episode. Now, it's important to hold the line here. Mass graves are emotionally powerful, and they can distort our sense of frequency. A massacre site becomes famous precisely because it is extreme and preserved. Most violence leaves no clear archaeological trace. Most bodies were not buried in ways that survive, and most settlements are not excavated to the degree needed to detect subtle trauma patterns. So the question becomes statistical. Do these violent sites appear often enough, across wide enough regions during the right time frame, to plausibly contribute to the genetic pattern? Many researchers think the answer is yes, if you combine violence with a specific social structure. Patrilineal descent is that structure. Because patrilineal descent changes what conflict does. It turns conflict into lineage pruning. If men remain and women move, if women are exchanged through marriage and men stay tied to land and inheritance, then male lines become geographically rooted and socially bounded. They become the backbone of clans. Meanwhile, female lines become the threads that connect clans, because women carry their mitochondrial DNA into new groups when they marry or are taken. In that world, wiping out a rival male group has an effect that goes beyond territory. It erases a branch of the Y chromosome tree, and you can get that erasure through direct killing, yes, but also through social domination. A conquering group that monopolizes reproduction, demotes rival males, and absorbs rival women. This is where the bottleneck can be produced without imagining a planet-wide extermination event. You don't need apocalyptic death everywhere. You need repeated outcomes, losing male lineages over and over because social rules decide who fathers children. So imagine a region with multiple villages, each dominated by a kin group that traces descent through fathers. Their land rights are inherited along male lines. Their status is inherited along male lines. Their protection is organized along male lines. The men are the continuity. Then conflict emerges over land, over water, over access to salt, flint sources, pasture, trade routes. A raid happens. It doesn't have to be a full-scale battle. It could be an attack at dawn when visibility's low and most people are inside. It could be an ambush on a path. It could be a retaliatory strike after a theft. The attackers kill adult men first. That's the immediate threat. They kill boys too because boys become men. And then, in some scenarios, they take young women, because young women are future reproduction, and reproduction is the ultimate resource in a patrilineal world. This is grim, but it's consistent with patterns seen in many ethnographic and historical contexts, where raiding and capture are part of warfare. From the perspective of genes, this is devastating. The women survive and reproduce, preserving mitochondrial diversity. The conquering men reproduce, spreading their Y line. The defeated men do not reproduce, or are killed, or are socially excluded. Their Y lines end. Repeat this over generations, across networks of communities, and you get exactly what the genetics shows: a collapse in effective male lineages, followed by a rebound as the survivors expand. But there's another mechanism that can amplify this even without constant killing: elite dominance. Agriculture produces surplus. Surplus produces storage. Storage produces control. Control produces hierarchy. A man who controls grain stores controls who eats in winter. A man who controls livestock controls bride wealth. A man who controls a defensible site controls who can settle nearby. That kind of control can translate into reproductive success. In many stratified societies, a small subset of men fathers an outsized portion of the next generation. Sometimes through polygyny, sometimes through serial partnerships, sometimes through coercive power, sometimes simply because status makes them attractive and stable in uncertain times. If early agricultural societies developed even moderate stratification, the reproductive skew could become extreme. The Y chromosome tree would narrow not because most men died, but because most men did not father sons who fathered sons. That's where the 17 women for every man idea becomes less like a battlefield ratio and more like a social geometry. Women are reproducing across many households. Men who reproduce are concentrated in fewer lineages. The hardest part is imagining just how fast this can happen. We tend to think of genetics as slow, but the Y chromosome is a record of lineages, and lineages can collapse quickly if social rules consistently favour certain men. A few centuries is enough, 10 generations, 15, 20. If in each generation most men fail to reproduce while a few lines dominate, you can lose enormous diversity. Now add movement. Because the Neolithic is not a static world of settled villages that never shift. It is also a period of expansion and migration. Farming spreads into new territories. New groups appear. Old groups are assimilated. Migration creates founder effects. A new region populated by a small group carries only a slice of Y diversity. If that founding group grows rapidly, it can dominate the genetic landscape of a large area. So now you have a plausible composite model. In some regions, violence and capture. In others, elite dominance and reproductive skew. In others, founder effects from migration. In many places, all three interacting, and the Y chromosome bottleneck becomes less like a single event and more like a long grinding filter, a period when social structures repeatedly narrowed male lines across wide populations. This is where ancient DNA becomes the turning key. Modern DNA can show you the shape of the tree, but ancient DNA can show you the tree in motion. When you extract genetic material from skeletons in Neolithic cemeteries, you can sometimes see patterns of kinship that are almost shockingly clear. Clusters of graves where many males share closely related Y chromosomes. Women in the same cemetery show much more diversity in mitochondrial lines. That pattern is exactly what you would expect if the community was patriarchal. Men stay, women move in from outside. And if you see that pattern repeated across region after region, you begin to understand how a male line bottleneck could be generated by social organisation alone, even if the archaeological evidence for direct violence is patchier than the genetic signal suggests. But then you see something else in ancient DNA that complicates the picture again: abrupt replacements. In certain times and places, genetic profiles shift rapidly. New Y lineages appear, old ones disappear. Sometimes the transition aligns with new material culture, new pottery styles, new burial practices, new weapon types. Sometimes it doesn't, which raises a question that archaeologists have wrestled with for over a century. When culture changes, is it ideas moving or people moving? Ancient DNA gives you a partial answer. Sometimes it's both. Sometimes it's mostly ideas. Sometimes it's mostly people. And in the context of the bottleneck, people moving can mean something stark. Not just migration, but displacement. One male-dominated group expanding into another group's territory. That expansion can happen through violence, or through social dominance, or through a mixture. The genes don't tell you motive, they tell you outcome. So imagine a frontier, a line where early farmers meet foragers, or where one farming culture expands into another's territory, or where climatic shifts force groups into closer competition for the same river valleys and arable soil. On that frontier, you don't need total war across an entire continent. You need repeated, localized episodes where certain male lines are extinguished and others spread. Over centuries, those local outcomes compound into a continental pattern. That's how bottlenecks are born, not necessarily from one apocalypse, but from many smaller collapses layered together. And once you accept that, the Neolithic Y chromosome bottleneck stops being a single mystery and becomes a lens. It becomes a way to see the early agricultural world with new eyes, because the official mental image of the Neolithic, quiet villages, steady progress, simple lives, was always incomplete. Not wrong, exactly, just incomplete. People did farm, they did build, they did cooperate, they did trade, they did form families and raise children and bury their dead with care. But they also lived in a world where property had begun to exist in a new form, and where social organization had become rigid enough that the loss of one clan could erase a lineage forever. And if you want to feel how real that is, you don't have to imagine emperors or armies. You can imagine a single winter. A winter when the grain stores are low. A winter when a neighbouring village has a better harvest. A winter when a disease hits the livestock. A winter when survival becomes a calculation and morality becomes a tool rather than a guide. In that world, the decision to raid is not a philosophical debate. It is a desperate, brutal strategy. And strategies that work tend to spread. So you get imitation, escalation, retaliation, cycles. A village builds a ditch because another village raided last year. Another village builds a higher palisade because the ditch didn't stop the last attack. Someone invents a better spear point. Someone else invents a stronger gate. Someone begins to organize young men into a permanent raiding group rather than occasional defense. And slowly, almost invisibly in the archaeological record, you can cross a threshold. Conflict becomes institutional. It becomes part of the social system, not an exception to it. That threshold may be one of the most important changes in human history. Because once violence becomes organized around lineage and land, it starts sculpting not just politics but biology. And that brings us back to your family tree. If you are male, that unbroken Y line running through your father's father's father is not just a curiosity, it is a survivor's thread. It passed through a period when most such threads snapped. It passed through centuries when a man's ability to reproduce could depend not only on health and chance, but on whether his kin group won a conflict, whether his village held its ground, whether his lineage retained status, whether his sons lived long enough to have sons. Even if you never think about it again, that pressure shaped you indirectly. Not by making you violent, not by making you destined for anything, but by narrowing the ancestral corridor through which you arrived. And it narrowed it so dramatically that 7,000 years later, geneticists can still see it. But the bottleneck isn't just a story about men. It's also a story about women, about movement, capture, marriage, and the silent continuity of maternal lines. Because in almost every model that explains the male-biased bottleneck, women are the carriers of continuity across disrupted landscapes. They are the ones whose DNA remains diverse, even when male lines collapse. They are the bridges between kin groups, and that has a chilling implication too. In a world where male lines are extinguished and replaced, female survival does not necessarily mean female agency. It can mean integration under new power structures. It can mean being taken from one life and inserted into another. It is possible, in other words, that the genetic stability of maternal lines is recording not peace, but absorption. This is where the data becomes morally heavy, because genetics can reveal patterns that sound sterile in scientific language, but represent real human experiences when translated into life. A lineage replacement can be a marriage alliance, or it can be violence. A reproductive skew can be status and attraction, or it can be coercion. A bottleneck can be migration and founder effects, or it can be systematic elimination. Often it's a mix, and the mix likely differed region by region. So the most responsible documentary voice does not lock onto one dramatic explanation and treat it as certainty. It holds multiple mechanisms in view and asks which combination best fits the total evidence. The challenge is that the Neolithic is still partly dark, not because nothing happened, but because what happened was not recorded in writing and because the archaeological record is uneven. We have bones, but not all bones. We have settlements, but not all settlements. We have DNA, but not from every region, not from every time slice, not from every social class. We have tools, but not the hands that held them. We have ditches, but not the meetings where people decided to dig them. So the bottleneck remains both clear and mysterious at the same time, clear in its genetic signature, mysterious in its lived detail, and that's why it's so powerful as a subject for a documentary script, because it forces you to hold a paradox. The past can be statistically visible while remaining personally unknown. But the paradox doesn't end there. Because once you accept that a society can reshape its genetic future through social structure, you have to ask a question that is difficult to avoid. Was the Neolithic bottleneck a one-off accident of history, or was it the first instance of a repeating pattern? In other words, when humans build systems, property systems, inheritance systems, hierarchy systems, do those systems inevitably concentrate reproduction and erase diversity? Do they turn humanity into a funnel, again and again, selecting a few lineages to dominate while others vanish? If that sounds abstract, consider something simpler: surnames. In many modern societies, surnames pass through male lines. They are cultural Y chromosomes. Track surnames over centuries and you see the same math. Many surnames disappear. A few expand. A handful become extremely common. The mechanism is not always violence. Often it's demography, status, and chance. But the pattern is still a funnel. Now translate that into the early Neolithic, when male line descent wasn't just a name but a claim to land, to grain, to animals, to protection. The funnel tightens, and in that tightening, 95% of male lines fade out of the genetic record. But what happens next is just as important as the collapse. Because after the bottleneck, the tree branches again. Male diversity begins to return. New lineages appear. Populations expand. Larger communities form. Trade networks intensify. Metallurgy spreads. Wheels roll. Horses change distances. Cities rise. And here's the question that should keep you awake even as you're trying to fall asleep. What, exactly, changed in the social physics of humanity that allowed male lineages to rebound? Was it simply that populations became larger, making it harder for drift and skew to erase diversity so quickly? Was it the emergence of more complex political structures, chiefdoms, early states, that suppressed constant small-scale raiding by enforcing broader peace? Was it the diffusion of power, iron tools, new farming techniques, that made survival less dependent on a single lineage's control? Or did the mechanism of replacement simply shift form, less about exterminating villages and more about absorbing them, less about erasing lineages and more about diluting them? To answer that, you have to move forward in time, out of the Neolithic villages and into the proto-urban world where records begin to appear. Because writing doesn't just preserve stories, it preserves administration, it preserves who owns what, who owes what, who belongs where. It turns fluid kinship into formal bureaucracy. And once bureaucracy exists, lineage doesn't vanish as easily. It becomes registered, taxed, enumerated, controlled. In a strange way, the rise of states may have protected male diversity, not because states are benevolent, but because states monopolize violence. They reduce the frequency of endless small clan wars by centralizing conflict under larger structures. But centralized structures create their own bottlenecks, different kind, different scale. Empires, for example, can spread the lineages of elites widely, through conquest, through privilege, through status that magnifies reproduction. So the funnel never goes away. It changes shape. which means the Neolithic bottleneck might not be the only one. It might be the most dramatic, the most visible, the one that happened when social systems first became powerful enough to reshape the genome on a continental scale. And if that's true, then the bottleneck is not just a story about what happened to your distant ancestors. It's a story about the relationship between structure and survival, about how the rules of society can become a force as real as climate or disease. Because if social rules can erase 95% of male lineages in a millennium, then human biology is not only shaped by nature, it is shaped by governance, by inheritance, by ideology, by who is allowed to marry, by who is allowed to own, by who is allowed to live. And that is a different way of thinking about evolution, not the slow grind of random mutation and selection in forests and savannas, but the sharp, deliberate shaping of populations by human systems. Which brings us to the most unsettling possibility of all. If the Neolithic bottleneck was produced by the emergence of property, patrilineal descent, and competitive territoriality, then it may represent the first time humanity crossed into a mode where social architecture could create near-extinction events for lineages without collapsing the species. In other words, humanity learned how to prune itself, not intentionally in the modern sense, but as an outcome of how we organized life. And once you learn a capability like that, once a species discovers that its own social arrangements can be as lethal as predators, you don't truly go back. You just build new versions, new hierarchies, new borders, new rules, and the genome keeps recording the consequences silently long after the stories have been forgotten. So when you trace your father's line backward and you imagine it passing through 7,000 years ago, you're not just imagining one mysterious catastrophe, you're looking at a hinge in the human story. A moment when farming did more than feed us. It reorganized us. It changed how people belong to land, how people belong to each other, how power moved through families, and how survival moved through bloodlines. And somewhere in that reorganization, whether by massacre, by dominance, by migration, by skew, or by all of them together, the vast majority of male lineages fell away, leaving only a handful to carry the future forward. But the story doesn't stop at the bottleneck, because the bottleneck is a clue, and clues point to deeper structures. The next step is to take that clue and follow it into the places where the genetic record meets the ground, into cemeteries where kinship can be reconstructed grave by grave, into settlement patterns where defensive architecture tells us what people feared, into isotopic signatures in teeth that reveal who was local and who was not, into the small details that turn population genetics back into human lives. Because somewhere in those details is the real story of what happened to the men who vanished, the women who endured, and the societies that transformed so violently that their echoes still sit inside you, unchanged, like a quiet message carried through thousands of fathers in the dark. Now imagine you're standing on the edge of a Neolithic cemetery at dawn, not a grand necropolis with marble and inscriptions, just a low rise in the earth, a patch of ground that looks ordinary until you know what's beneath it. A cluster of graves, a few stones, a faint ridge where the soil has been disturbed over and over, generation after generation, as the living return to place the dead into the same ground. For an archaeologist, this is where the bottleneck stops being a curve on a graph and starts becoming a map of relationships. Because bones don't just tell you how someone died. With the right tools, they can tell you where they grew up, what they ate, whether they moved, whether they were local or foreign to the settlement where they were buried, and if you can extract DNA, the bones can tell you who they were related to, not in a vague sense, but with almost family tree clarity. A father and son buried a few meters apart, brothers, cousins, an uncle, a line of men sharing the same Y chromosome signature, stacked in time like a sequence of candles burning down through the centuries. And then, scattered among them, the women. Women who share far fewer maternal lines than you'd expect if everyone in the cemetery was born in the same place. Women whose mitochondrial DNA looks like it came from many different sources. Women whose tooth chemistry sometimes indicates childhood in a different region, a different valley, a different geology entirely. That pattern, men genetically similar, women genetically diverse, shows up again and again in early farming contexts. It's one of the strongest signals we have for patrilocality, men staying in their birthplace, women marrying in. And once you see it, the bottleneck mechanism becomes less like a theory and more like a system. In a patrilineal system, a village is not just a settlement, it is a lineage machine. The land belongs to the male line, the houses belong to the male line, the social identity belongs to the male line. The women are the moving parts, the connectors, the imports that keep the village's alliances alive, that reduce conflict, that exchange genes and skills and information across the landscape. But those same moving parts make the genetic signature vulnerable in a specific way. If a village is destroyed, the male line can end in one episode. The women's lines can continue elsewhere, because women can be absorbed into new communities in ways that men, socially, often cannot. And that absorption is visible if you know how to look for it. It's visible in the mitochondrial continuity across cultural transitions. It's visible in isotopes. It's visible in burial treatment, who is buried with the local style and who is not. It's visible in the sudden appearance of women with foreign origins in a community that otherwise looks stable. In the old way of telling human prehistory, this would be framed as marriage exchange, and sometimes that is exactly what it is. Alliances, bride wealth, negotiated movement. A cultural mechanism that reduces violence by linking groups through kinship. But in the world that produced the bottleneck, that same mechanism can also become a conveyor belt of replacement. Because if one group begins to dominate another, through raiding, through coercion, through advantage, then women become the channel through which a population can persist even as its male lines are erased. A maternal line can survive conquest. A paternal line often cannot. So the next step is to turn from cemeteries to frontiers. Because the bottleneck didn't happen in a vacuum, it happened during expansion. Agriculture spread like a tide, but not a smooth one. More like water pushing through a broken landscape, filling lowlands first, following rivers, pooling in fertile basins, leaving some regions untouched for centuries while others were transformed quickly. And wherever it spread, it met people who were already there. Foragers, pastoralists, other farmers, older settlements with older claims. This is where we start seeing the deep tension in the genetic story. Continuity and rupture braided together. In some regions, ancient DNA shows continuity between early farmers and later populations. That suggests assimilation, intermarriage, gradual change. In other regions, the genetic signatures shift abruptly. That suggests replacement, whether by migration, domination, or both. And the most famous of those abrupt shifts, the one that keeps returning to the debate like a shadow, is the steppe horizon. The Yamnaya-related expansions out of the Pontic-Caspian steppe during the late Neolithic and early Bronze Age are not exactly the same time frame as the deepest part of the 7,000-year bottleneck, but they overlap the broader period of lineage turbulence that follows, and they demonstrate something crucial. Male-mediated movement can reshape the genetic landscape extremely fast. In the ancient DNA record you can see it. a region with one set of Y lineages. Then, within a relatively narrow time window, the dominance of different Y lineages associated with incoming groups, sometimes with evidence of substantial admixture with local women, sometimes with a sharper edge that looks like demographic displacement. This pattern doesn't prove a single unified narrative, but it proves the principle. You don't need slow drift over millennia to rewrite male lineages across vast territory. Under certain social conditions, you can do it in centuries, and once you accept that, the Neolithic bottleneck becomes less impossible, because the bottleneck is essentially a global-scale version of that principle, operating across earlier, smaller, more fragmented systems. What the step expansions show is what happens when mobility, horse-based transport, new social forms, and competitive advantages enter the equation. The bottleneck in turn may show what happens when the earliest forms of land-based inequality and patrilineal competition first ignite. But the story gets sharper when you zoom in on specific micro-regions. Because Europe is too big, Asia is too big, even Central Europe is often too big. The bottleneck signature is a broad average drawn from many local histories, and those local histories differ. So pick a river valley, a place where soil is rich and water is reliable, where farming makes sense, where settlements cluster, where the landscape itself encourages people to stay. In such a valley, you can often trace settlement sequences, an early village, then another nearby, then a later one built close to the earlier footprint. You can see ceramics change style. You can see house plans shift. You can see toolkits evolve. You can see minor disruptions and then stability. Then, at some point, you see stress, more defensive architecture, more signs of trauma in skeletons, more evidence of hurried abandonment, sometimes burned layers, and in parallel, if you have DNA, you can see Y lineages narrowing, one lineage becoming common, another disappearing. This is the part of the story that feels less like myth and more like ecology, because once humans settled, the landscape became crowded in a new way. Not crowded in the modern sense of millions, but crowded in the sense that choices were constrained. Fields take years to establish. Soil fertility can be exhausted if managed poorly. Grazing pressure can alter vegetation. Local resources become contested. Small differences in climate can turn into crises. A run of wet years can rot stored grain and spread disease. A run of dry years can collapse harvests and drive raiding. A single late frost can destroy the crop at the wrong moment. A livestock epidemic can kill wealth on 4 legs. In a world where surplus is stored, collapse is not always gradual. It can be sudden and social. Hunger makes politics violent. Fear turns neighbours into enemies. Rumour becomes a weapon. And under those conditions, lineage-based organisation becomes both protection and trap. Protection because your kin group defends you. Trap because your kin group makes you a target. If an attacking group is thinking in lineage terms, if identity is clan-based, then wiping out the male backbone of a rival group isn't just revenge. It's prevention. It removes the possibility that the rival line rises again to contest the land. This is where the genetic and archaeological narratives begin to align in an unsettling way. You don't need to imagine every conflict ending in massacre. You only need the conflicts that end decisively to have disproportionate genetic impact. Because a decisive lineage-ending event removes a branch permanently, while decades of minor skirmishes do not. That means the genetic signature can be shaped by a minority of extreme events, and the archaeological record, biased toward preserving dramatic destruction, would naturally preserve those extreme events more than the day-to-day tension that preceded them. So the massacre sites we find may be the visible peaks of a much larger invisible pressure field. Chronic hostility, territorial competition, vendettas, cycles of retaliation, and shifting alliances. And once the cycles begin, they can persist long enough to create the bottleneck. But there's another layer to this story that often goes unnoticed, and it sits inside the math of effective population size. When geneticists talk about effective male population size, they do not mean the literal number of men alive. They mean the number of men who successfully contribute Y chromosomes to the next generations in a way that persists. This is crucial because it means societies can create bottlenecks without mass death simply by limiting who reproduces. In a patrilineal system, certain males can become reproductively invisible for reasons that are not biological. If inheritance goes to firstborn sons and land is limited, younger sons might become dependents, migrants, raiders, or non-reproducing labourers. If bride wealth is required, men without cattle or grain might be locked out of marriage. If elite households control resources, they can monopolize spouses. Even in monogamous ideology, social inequality can produce practical polygyny through serial partnerships, concubinage, unequal remarriage opportunities, and power-based access. Over generations, this turns a population into a reproductive pyramid. Many men at the base, fewer men in the middle, very few men at the top producing most surviving lineages. From the outside, the village might look stable. No smoke, no ruin, no massacre pit. But from the inside of the Y chromosome, the lineages are being filtered. This is why some of the most plausible models of the bottleneck involve both forces at once. Violence eliminates lineages abruptly. Reproductive skew eliminates lineages quietly. Migration amplifies the winners, and the combined effect is a bottleneck that can persist for centuries. Now, if you want to understand how that could become global, or at least widespread across Eurasia, you have to think about networks. The Neolithic is not isolated villages living in total separation. There are trade routes, even if they are not paved roads. Obsidian moves long distances, salt moves, spondylus shells move, amber moves, ideas move, rituals move, styles move, and where networks exist, conflict can spread too. Because once a region becomes interconnected, the failure of one community can ripple outward. A disrupted trade route can starve craft specialists of materials. A collapse of trust can turn exchange into raiding. A shift in power can redraw alliances. A successful raiding group can inspire imitation. The bottleneck, in this sense, can be understood as a network phenomenon. Not one war, but a phase shift. An era in which the social logic of lineage competition became widespread enough that male lines were systematically vulnerable across broad connected regions. And we can see hints of that phase shift in the sheer intensity with which some communities began to invest in defense. Defense is not built for one bad day. It is built for a new normal. A ditch isn't dug because of a rumor. It's dug because threats are real enough to justify pulling people away from fields and making them do nothing but move earth. And the most telling part is that defenses become cultural. They appear as a style of living. Some houses are oriented inward. Some settlements cluster tightly rather than spread. Some communities place their wells inside walls. Some store grain in ways that hide it, not because they don't trust weather, but because they don't trust people. When you see that, you begin to understand something that the genetic signature implies, but cannot say out loud. Fear was part of the Neolithic. Not occasional fear, structural fear, a kind of background tension that shapes reproduction, migration, and survival. And fear has a genetic footprint because fear changes behavior. Fear changes where you move, who you trust, who you marry, how many children you have, whether your sons live long enough to have sons. Now, there's a specific kind of data that can make this even more concrete, and it comes from the chemistry of teeth: strontium isotopes. In childhood, your teeth mineralize using elements from your local water and soil. Different geological regions have different strontium signatures, so years later, if you analyze the enamel of a skeleton's teeth, you can sometimes determine whether that person grew up locally or elsewhere. In many Neolithic cemeteries, the strontium signatures show a pattern. Men more often local, women more often non-local. That is patriolocality in chemical form. But in some cases the pattern becomes sharper. You see pulses of non-local women arriving in a community, not scattered evenly across centuries but clustered in time. And that can be interpreted in more than one way. It can mean a period of intensified marriage exchange, alliances forged, networks widened. Or it can mean something darker, a period in which women arrive through capture or displacement, not negotiation. The isotope data cannot tell you motive, but when you align it with other evidence, trauma patterns, settlement defences, changes in burial treatment, it can start to suggest whether a community was absorbing women under peaceful terms or under pressure. And the more you integrate these lines of evidence, the more the bottleneck starts to look like a lived landscape rather than an abstract mystery. A landscape of villages that are lineage clusters, a landscape of women moving between those clusters, a landscape where certain male lines expand and others vanish, and a landscape where the social threshold of agriculture, fixed land, stored wealth, inherited property, turns lineage competition into a force strong enough to reshape the genome. But we still haven't touched the most haunting implication of the bottleneck, that for a long period, the reproductive future of humanity may have been controlled by a very small number of male lines. If that sounds like an exaggeration, remember what effective population size implies at the deepest part of the bottleneck. A drastic narrowing. In practical terms, it means that across large regions, the vast majority of surviving descendants trace their paternal lines back through a relatively small set of male ancestors from that era. Not one ancestor, not a single Adam, but a small club of fathers whose lines made it through while countless others did not. And that kind of narrowing has a cultural echo. Because when only a few male lines dominate, social memory changes, legends change. Genealogies become political tools, lineage becomes status. Being descended from the right fathers becomes a claim. You can feel the beginnings of that in later ancient societies, when kings list their ancestors like armour, when dynasties justify rule through blood, when lineages become divine narratives. The bottleneck may be one of the prehistoric roots of that obsession, a world where lineage truly determines survival, and if you take that seriously, the bottleneck stops being merely a prehistoric demographic curiosity. It becomes a clue to why humans became the kind of species that builds patriarchies, dynasties, and inheritance-based power structures, not because biology forces culture, but because culture can shape biology. And once certain cultural strategies worked, they became templates that later societies copied, refined, scaled up. The Neolithic bottleneck could be one of the first times those templates became dominant enough to leave a visible scar. And yet, even with all of that, a careful historian still has to hold the uncertainty. Because the bottleneck is real, but the exact mixture of causes is not fully resolved. Some regions may have been relatively peaceful, with bottleneck effects produced mostly by social stratification and reproductive skew. Other regions may have been violent frontiers, with repeated lineage-ending raids. Some areas may have seen major migrations that amplified certain lines. Some places may have been insulated, showing weaker bottleneck signatures. The bottleneck is not a single story. It is a broad phase of human history in which male lineages became unusually fragile across many connected populations. And that fragility is the point, because it means that the rise of agriculture did not simply increase population, it increased risk. Not the risk of starvation alone, but the risk of being erased, socially, genetically, permanently. If you were a Neolithic man in a small patrilineal community, your survival was not only your own, it was the survival of your line, and your line might end not because you were weak or sick, but because your community lost a conflict, because your household fell in status, because land ran out, because alliances shifted, because a raiding party decided that your village's male backbone had to disappear. And that is the kind of pressure that changes what a society becomes. It pushes communities to harden. It pushes them to organize. It pushes them to defend. It pushes them to control marriage and inheritance. It pushes them to form larger coalitions, because isolated villages are easier to erase than confederations. And that brings us to the transition that follows. The slow rise of larger social units, capable of dampening the constant local cycles of conflict. Chiefdoms, proto-states, regional authorities, early forms of organized law. Not necessarily humane, not necessarily fair, but stabilizing in a brutal way, by concentrating violence and regulating who can raid whom. The bottleneck begins to ease when society scales, because once you have larger systems, lineages become less likely to be erased in a single localized event. Migration and intermarriage increase, networks widen, populations grow, drift becomes weaker, reproductive opportunity spreads. In genetic terms, the tree begins to branch again, but branching is not the same as peace. It simply means the corridor widens, more lines survive, more men reproduce, more Y chromosome variation persists into the future, and that future is what you live inside now. You are not just a modern person with modern concerns. You are the end point of an ancient filtering process in which social structure acted like a selective force. Even if you don't carry a Y chromosome, you still carry the consequences, because the bottleneck shaped the populations that went on to become the ancestors of later societies. It shaped migration flows, power structures, and demographic baselines. And the evidence of it is not just hidden in labs, it's waiting in the ground, in the cemeteries, in the ditches, in the scars on bones, in the chemistry of teeth, in the patterns of who was buried and who was taken elsewhere. So the next time someone tells you the Neolithic was simply the dawn of peace and progress, you can hold a more precise image in your mind. A dawn, yes, but a dawn with shadows, with a world where the invention of farming also invented new kinds of competition, where the first stored grain made raids profitable, where inherited land made borders meaningful, where patrilineal clans made lineage both identity and vulnerability, and where, across centuries, the human Y chromosome recorded the outcome with ruthless clarity. Most lines ended, and a few survived to seed the branches you see today. And if you let that sink in, really sink in, you begin to see the bottleneck not as a closed case, but as an opening. A doorway into the deeper question of human history. When our social inventions become powerful enough to shape our biology, what else have we already done to ourselves without noticing? And that deeper question doesn't stay in the Neolithic, because once you accept that culture can compress or expand genetic diversity, once you accept that social rules can behave like selection pressures, you start seeing echoes of the same mechanism in later history. Not always as dramatic, not always as clean in the data, but recognizable in the structure. A lineage doesn't have to be killed to disappear. It can be priced out of marriage. It can be pushed off land. It can be absorbed into another identity until its name and memory vanish. It can be outcompeted in a system where reproduction is not a right but a privilege. And the Neolithic is the first time we see that system take hold at scale, not in scattered micro-episodes, but as a long grinding phase, centuries in which the rules of settlement, inheritance, and territoriality made paternal continuity unusually fragile. The irony is that the same period we associate with stability, permanent houses, fenced fields, stored grain, may have been one of the most volatile genetic eras in human history. Not because people were constantly dying everywhere at once, but because the stakes of conflict changed. When you're a hunter-gatherer, the worst loss is often a person. When you're a farmer, the worst loss can be a place, and a place is not easily replaced. The moment land becomes inherited, your children's future becomes tied to it. Your lineage becomes tied to it. Your identity becomes tied to it. So when land is threatened, your response is different. The moral arithmetic changes. The willingness to use violence changes. The willingness to accept outsiders changes. And that's why the bottleneck has such power as a story. It forces you to look at agriculture not as a simple technological upgrade, but as an ecological trap with cultural consequences. A trap that pulled humans into a new kind of competition. A trap that rewarded consolidation. A trap that punished weakness. A trap that made certain social strategies, patrilineal solidarity, alliance building, territorial defense, survive and spread. If you want to feel how quickly that kind of world can narrow the future, don't imagine it in terms of continents. Imagine it in terms of 3 villages. Village A sits on a bend in the river where the soil is black and deep. Their harvest is dependable. Their cattle are healthy. Their storage pits are full. Village B is a day's walk upstream. Their fields are thinner. Their harvest is less stable. A bad year hits them harder. Village C sits between them, on a ridge where water is harder to access but visibility is excellent. They trade with both A and B. They marry into both. They're a hinge in the network. Now imagine 2 consecutive dry summers. B's harvest fails, then fails again. C can't buffer the pressure because C was never rich enough to feed 2 others. A is fine, but only if A protects its stores. In a world without states, without police, without a permanent authority that can enforce rules across the valley, the system defaults to the oldest enforcement mechanism humans have: force. B can attempt negotiation. B can offer labor. B can promise future grain. But promises don't feed children in the present, so B raids. A repels the raid and loses 2 men. A retaliates not to recover grain that's already eaten or hidden, but to remove the threat. A raids B, not for wealth, but for certainty. And in a patrilineal system, certainty is achieved by breaking the backbone of male defenders, killing the men who would otherwise raid again, taking women because women preserve fertility, and fertility is the only true recovery in a subsistence world. C, position between them, is forced to choose. Alliances harden. Marriage exchange stops being purely social and becomes strategic. Lineage becomes political. Within a few generations, one village's male line dominates the valley, not because their men are inherently superior, but because their social position allowed them to win the critical sequence of conflicts, and those wins propagated. This is how a bottleneck can happen without a single apocalyptic event. It's a long cascade of smaller crises that repeatedly select the same kinds of winners. And when you scale that model outward, when you apply it across hundreds of river valleys, across thousands of communities, across centuries where climate pulses, resource pressure, and cultural innovation collide, you can begin to see how 95% of paternal diversity might disappear. Not in a day, but in a phase in which lineages were constantly being tested, and most failed. There's one more layer that makes this even colder, and it has to do with what archaeologists call success. When we see a cultural horizon expand, when we see a pottery style spread, a burial practice appear across large territory, a settlement pattern replicate, we tend to interpret that as diffusion of ideas, as people learning from neighbours. Sometimes that's true, but sometimes a cultural horizon expands because the people carrying it are expanding, and sometimes that expansion is not neutral. In the genetic record, you can see cases where cultural change aligns with a shift in paternal lineages more strongly than maternal ones. That suggests a particular direction of movement, male-driven expansion with local female assimilation. In plain terms, men arriving, women absorbed. That pattern is not constant across all regions and eras, but when it appears, it acts like an engine for bottlenecks. It amplifies a small number of male lines rapidly. It spreads their Y chromosomes across space. It turns local demographic advantage into continental-scale ancestry. And this is where the Neolithic bottleneck becomes something more than a puzzle about the past. It becomes a warning about how fast human societies can rewrite themselves when power concentrates. Because the bottleneck isn't a natural law, it's a consequence of social architecture. Change the architecture, and the genetic outcomes change. If women remain in their natal groups and men move, the pattern looks different. If inheritance is flexible, the pattern looks different. If marriage access is broad, the pattern looks different. If raids are punished by a larger authority, the pattern looks different. The bottleneck is a fingerprint of a particular set of rules that dominated long enough to leave a scar. And once you recognize that, you start seeing why the bottleneck ends when larger systems appear. Not because large systems are gentle, but because large systems distribute risk differently. They create wider marriage networks. They force peace in some zones even as they wage war in others. They allow populations to grow large enough that random lineage loss matters less. They create institutions that outlast single households. A village can lose its men and vanish. A city can lose its men and replace them. A state can lose an army and raise another. Scale changes everything. Scale turns lineage extinction from a common outcome into an exception, so the bottleneck narrows the tree and the rise of complex societies begins to widen it again. But the old pressure never disappears. It changes form. In later eras, you can see paternal lineages expanding again through new mechanisms, empires, elite dominance, conquest, social stratification. Not always as severe as the Neolithic event, but real enough that genetics can detect them. A successful elite male line can leave thousands of descendants. A dynasty can reshape a region's ancestry. A warrior aristocracy can flood a landscape with a narrow slice of paternal variation. The Neolithic bottleneck may have been the first major demonstration of that principle, that in human societies, reproduction can be politically structured, and politics can become biological. Now take your family tree again. Trace your father's line backward through time. At first it's names and stories and maybe a handful of documents. Then it becomes a fog. Then it becomes silence. And finally it becomes molecules. Your Y chromosome, if you carry one, is the last surviving thread of an unimaginably vast tapestry that once existed. It is not superior to the threads that vanished. It is simply the one that made it through the narrowing corridor of those millennia. And if you don't carry a Y chromosome, the corridor still shaped the world that produced you. It shaped the communities that survived, the migrations that happened, the alliances that formed, the power structures that became templates. Either way, you are standing downstream from a historical event that no one witnessed with writing, no one recorded on stone, and yet every modern geneticist can see. That's the unsettling beauty of it. History can be hidden, but it can't be fully erased. Because the body remembers, and when the body remembers something this dramatic, it forces a final question, one that sits at the edge of anthropology, genetics, and uncomfortable human self-recognition. What does it mean that our species' deep history contains not just migrations and inventions, but eras where social structure made most male lines disposable? What does it mean that the agricultural revolution, the foundation of everything we call civilization, may have been accompanied by a shadow process of lineage pruning on a scale almost too large to imagine? And what does it mean that the forces capable of doing that, inequality, territorial competition, organized violence, elite reproductive skew, are not relics of prehistory, but recurring features of human societies? The Neolithic bottleneck is not proof that humanity is doomed to repeat an ancient war, but it is proof that human systems can become powerful enough to shape the future at the level of ancestry. It is proof that progress and catastrophe can coexist in the same era. Fields and fortifications, granaries and graves, permanent homes and sudden erasures. And perhaps that's the most honest way to understand the dawn of civilization, not as a clean turning point, but as a threshold crossed with consequences, some bright, some brutal, still echoing inside us. So as your mind slows tonight, let the image settle gently. A world of early farmers under open sky, a world of small villages clustered around water and soil, a world where kinship was a fortress, a world where a man's line could end in one bad season, one raid, one shift in alliance, and above that world unseen, a genetic record forming in silence, mutations ticking like a clock, lineages branching, then collapsing, a vast tree narrowing into a thin bundle of surviving strands, until, thousands of years later, science learns to read the code, and discovers that beneath the familiar story of civilization's birth, there was another story running in parallel, a story written into the Y chromosome, a story of a bottleneck so deep that most fathers in prehistory left no paternal descendants at all. A story that ends, not with a neat answer, but with a quiet recognition. You are here because someone survived that corridor. And the corridor was shaped not only by nature, but by humans,